quality control captivates your party patrol. Your mind, body, and soul flow. The bell tolls like the rhythm explode. Big, bad, and bold.
Hello and welcome to the concepts video on solving trig equations. So in this video I'm just going to demonstrate a method on how to, well, not a method, there's no set method really, but a way how to solve different kinds of equations using the knowledge that we do know about trig functions and their inverse functions and everything like that. So let's get started. Okay, so here's our first example. We're going to solve this equation here. Sine of t is equal to 1/2 for all possible values of t. Okay, so the important thing here is to note that we see all possible values of t. So let's get started. So we're going to say, okay, so what t gives us a sine, an output of 1/2. So sine is like our y value on the unit circle, right? So 1/2 would be around here. So we have sine, our angle could be pi over 6. Or our angle could be 5 pi over 6, right? So those are two solutions. So that should be it, right? No, not necessarily. We have kind of like one of those things, but wait, there's more kind of thing, because that was just when we run around the unit circle once. What if we keep going around, okay? Then we'll hit some other things, such as, not equals to, sorry, not the equals, a comma. We could also have pi over 6 plus another 2 pi, which means you went around one more time. How about 5 pi over 6 plus another 2 pi? Okay, you went around another time from there. So, and you can even subtract off 2 pi. We could also have a solution like pi over 6 minus 2 pi. That means we went in the opposite direction just once around. We could have 5 pi over 6 minus 2 pi. And we can do even more and more multiples of 2 pi. So a common way that we write solutions like these are kind of like a solution set. So we could write, instead of all of this mumbo-jumbo, where we'll never be done, basically, we could write pi over 6 plus or minus 2 pi, and then write like a k there, where k is a positive integer. Any positive integer you want. Okay? So you could have pi over 6 plus 2 pi, where k is 1. You could have pi over 6 plus 4 pi. That way your k would be 2, etc., etc. We could also write the 5 pi over 6 1 as the same thing. We'll just tack on that extra plus 2 pi, plus or minus 2 pi k. So that just accounts for any time you can go around a full circle or a full 2 circles, or you can just add on revolutions. Okay? So this would be our solution set for this problem here. This thing that I'm boxing, this tells us all possible values of t, which would satisfy our equation. So here's another example we could have. It says a circle of radius 5 times radical 2 intersects the line x equals -5 at 2 points. Find the angles theta on the interval from 0 to 2 pi. So here we're limited to going around the circle once, where the circle and the line intersect. So let's start by drawing a picture of what's going on. So we have a circle. Okay, let me draw a circle here. So this is radius 5 times square root of 2. Okay, so we have 5 times square root of 2, so that's our radius, and it intersects the line x equals -5, so that'll be probably somewhere around here or so. I'm just kind of guesstimating here. X, that's an x, isn't it? Okay, so x equals -5, so x would be over here. There we go. So that would be a vertical line. So x equals -5 is this line here. So it says at 2 points. So we need to find this point here, we need to find that angle, and we need to find this angle here. Okay, so we need to find this angle as well as this angle there. Alrighty? So how are we going to solve for this? So x equals -5. So x equals -5. X can also be represented as r times cosine theta, right? So, and the thing is, we already know what our r is, because we were given that r is equal to 5 times radical 2 for this circle, okay? So if we kind of just set up this equation, we plug in the r, and we don't know theta, okay? But we do have this, that this thing should equal to -5, okay? So if we have this equation, let me write it a little bit more clearly down here. So what we can do is just divide by this 5 radical 2, divide by 5 radical 2. So this one cancels out. So we get that cosine theta should be equal to negative. The 5's cancel out and we can rationalize that. So that'd be radical 2 over 2. Okay, so now our new problem is this, and that looks a little bit more familiar to us, right? Because now we can use the unit circle and all of that stuff. So when is cosine equal to negative radical 2 over 2? That would be when we're at, well, 3 pi over 4 and a 5 pi over 4. And they told us in the beginning in the problem, it says find the angles on the interval 0 to 2 pi. So that means we only have to go around once and then just stop. We're not going to make any other revolutions here. So the angles are going to be theta is equal to 3 pi over 4. And we're going to have another angle is 5 pi over 4. Okay, and those are our solutions for that problem there. Sometimes we'll get a problem when we have a value that we don't really know on our unit circle. So let's say we get sine of, I don't know, something like 0.8, and we want to solve this equation. It's like, well, wait, what? 0.8 doesn't look like radical 3 over 2, it doesn't look like radical 2 over 2, it doesn't look like 1/2, and doesn't look like 1 or 0. So what am I supposed to do now? And the thing is, what we're going to do is utilize our information about the inverse functions. Okay, in this case, we're specifically going to take advantage of inverse sine. Okay, we know that inverse functions and their normal functions, well, basically functions that are inverses of each other, when you place them right next to each other, they kind of cancel out their effects. Okay, so let's say we were to write inverse sine of this thing that we started with on the left side, so that means we have to inverse sine the right side, okay, to keep that equality there. What happens on the left, like I was saying, is we have a function right next to its inverse, so these kind of cancel out, okay? So we just get out that theta, which we're looking for, and this is equal to sine inverse, or inverse sine, of 0.8. So at this point, we can just plug this into a calculator, keeping in mind that this 0.8 is in radians, okay? This is in radians. Be careful with that, alrighty? And so we're going to get that theta, when you plug this into your calculator, you get a value of about 0.927. This is not in radians, just kidding. That's just in units, just like a number. This thing is in radians. That's what I meant to say is whatever you're going to get out is usually going to be in radians, or it should be in radians. If you're in degrees, you'll get something different, but you can always convert using the pi over 180 thing. Okay? So, now that we get this converts to something like this. So this angle lies in the first quadrant. Okay, so this is like radians, so this is 0. When you go all the way around, 2 pi converts to, in like actual numbers, 6.28. So over here we'll have 3.14 because that's pi, of course. And then halfway in between is like 1.5 or 1.6 something. Anyways, so 0.927 is in the first quadrant, but we also know that sine must also be that same value on another point on our unit circle, right? And in order to obtain that, what we found was this theta here, okay? And this theta is actually going to be the same over here, so what we can do to find this angle, you measured from 0, from the angle 0, is we can take pi, we're going to take pi and subtract away whatever we got for our first angle. So that would be 0.927. And that would give us the measure of the angle, kind of like this. Got a little messy. The measure of this angle right here. Okay? So when we do that, the pi minus 0.927, we're going to get an answer of 2.214. Okay? Alright, so now from that, we're supposed to find all of the solutions to this equation. Okay? So to find all solutions, we just add and subtract multiples of 2 pi in order to keep going around and around and around our circle, right? So ultimately, our solution set is going to look like this. We have pi is equal to 0.927 plus or minus 2 pi k, and also 2.214 plus or minus 2 pi k. Alrighty? Okay, so here's the last problem, the last example for our concepts video. We're going to solve this equation here for all solutions, okay? So the first thing is to get sine by itself, so we can deal with it on its own. Okay, so we have sine pi t, pi times t is equal to negative 2 over 3. Okay, so we can kind of consider this thing on the inside. I'm just going to use like a pretty useful thing called u substitution. Right, so we're just going to consider everything on the inside of our sine function as u. So we kind of have like sine of u is equal to negative 2 over 3. Okay, So this thing, that's not a familiar value that we know on our unit circle. So what we're going to do is inverse sign both sides. Okay, so if we inverse sign the left side, we have to inverse sign the right side, which means we're going to need our calculator for this. So u is equal to, when we plug that in, inverse sign of negative 2 over 3, we're going to get an answer of negative 0.730. Okay, and so if we look on our unit circle, negative means in the clockwise direction, and 0.73 that lies in quadrant number 4. Okay, and so to get that same sign value, we also have another angle here which fulfills that. Okay, and what we're going to do in order to get that is note that this angle here that we found, that's basically the same angle over here. Okay, and then so once we find that, we just have to add 180 degrees to it, also known as pi, right? So we're just going to take the positive magnitude of this, okay? So we'll take 0.730, add pi onto it, okay? I don't know why I'm writing i's there. I was thinking pi. Anyways, okay, so we're going to add pi, okay? And that'll give us the other angle here. This one all in there. Okay, so that would give us this one if we rotate that many degrees, or that many radians, okay? And then when you do that, we're actually going to get an answer of, so the first one's the same, negative 0.73, and the other one's 3.871, okay? And then it says for all solutions, so we have to, again, add on our plus and minus 2 pi k, all right? So u is equal to negative 0.730 plus and minus 2 pi k, all right? And then comma, 3.871 plus minus 2 pi k, and looks like we're done. But we're not, because we didn't start with any u's, right? Because that was an invention that we kind of created. And u is equal to pi times t, right? Because we subbed that out in the very beginning to make our problem simpler while we worked through this whole inverse stuff. And now at the very end, what we're going to do is just divide by pi everywhere, so we can just get t by itself, okay? So if we divide both of these by pi, we just get that t is equal to, so when you divide by pi, again, we're going to break out our calculator here. So we get negative 0.232 plus or minus, and then we get 2k because the pi's cancel, right? And then our other solution, or our other solution set, is going to be positive 1.232 plus or minus 2k. Alrighty? And that's going to be all solutions to our equation above. Alright, so that concludes the concepts video on solving trig equations. I hope that helps, and I'll talk to you in the practice problems video if you watch.
We're going to take a trip back in time. Are you ready to get into your time machine? Okay, fasten your seatbelts. Are you ready?